So this is the second part of 6.1. I'm sorry, 1.6. And we've already seen that functions can be represented as maps and as tables. But now we're going to take a look at what happens when they give us a verbal rule or when they give us an equation and we're required to determine whether or not it's a function. Now, I know you're really familiar with this stuff. The idea that saying the output is equal to 2.3 more than the input. So we're using these words output and input for x and for y. The equation that's tied to that particular verbal rule, output y is equal to input increased by 2.3, or 2.3 more than each input. Remember, we can use these domain values. Remember, this is just a piece of the domain when we're talking about a line. We plug in those domain values 4, 5, 6, and 7 in place of x. So 4 plus 2.3 gave me 6.3. 5 plus 2.3 gave me 7.3. 8.3, 9.3. I wanted to call your attention to the fact that we're looking at here in adding 1 to each x value, and we're also adding 1 between each y value. The idea of saying how do the y's change compared to how do the x's change is where this number right here in front of x, that's where it comes from. It comes from what's the change, we use that triangle to mean change in y over change in x. So in this case, adding 1 is the y change, and adding 1 is also the x change, which is why we end up with a 1 in front of that x value. This is going to become important as we move into the next problem. Example 3. The domain of the function y equals 1/2 x plus 6 is 0, 2, 3, and 4. Make a table for the function, then identify the range of the function. So this problem doesn't have that verbal model involved, even though we could in fact write it. The output is 1/2 of the input increased by 6, or 6 more than half of each input. So I cheated and paused and I wrote that down for you. The output is 6 more than half of each input. It would be the verbal model. Even if we weren't asked for it here, we should have at least thought it. It asks us to fill in the table, so I filled in my x values, or my domain, 0, 2, 3, and 4, because that is what they gave me. Eventually, I'll get control over that, but for now, they're going to tell me what to put there. So I plug in the 0, 1/2 of 0 is 0, then add 6. So 0 plus 6 is 6. 1/2 of 2, and then add 6. Half of 2 is 1, and 1 plus 6 is 7. Now be careful. This interval, this change in x values, isn't constant, right? I added 2, then I'm going to add 1, then I'm going to add 1. So I'm not going to be able to apply a consistent change between my y's. I can't just say, oh, this increases by 1. I have to go ahead and go all the way through the process. Half of 3 is 1.5. 1.5 plus 6 is 7.5, or 7.5. Half of 4 is 2. 2 plus 6 is 8. So that the range of this function, of the given domain, the range is the set containing 6, 7, 7.5, or 7.5, and 8. Let's look at example 4. Given the domain and rule, now we have to write the equation and find the range. So they've given me a table of values. They've given me that verbal rule. The output, well, there's our y, is equal to twice the input. Twice, that means multiply by 2. And the input is x. So my equation to represent the rule is y is equal to 2x, which hopefully is pretty easy, right? Take each domain value that they gave us and multiply it by 2. So 2 times 0 is 0, 2 times 6 is 12, 2 times 11 is 22, and 2 times 18 is 36. Again, I want to point out that in this particular table, my change in x values is not consistent, right? I increased by 6, I'm increasing by 5, I'm increasing by 7. So that the idea of applying that change in y over change in x is not going to work here because our interval, our change in x, is not consistent. The last piece they asked us to do was to write down our range, and those are just simply those values: 0, 12, 22, and 36. And we'll put it in set notation. So we need those little set notation symbols. Set containing. Alright, here comes the last example, the one that I've been kind of priming you for. Now they've only given us a table, and we have to write both the equation and the verbal rule. It depends on how your brain works, which one of these is easier for you. Some people will be able to look at this table and come up with that rule right away. I'm not one of those people, so I'm going to show you what I would do to figure this out. I'm going to start with what's my change in x's. This one changed by 1. It's an increase of 1. This is an increase of 3. And this is an increase of 6. I'm going to go to my y values, because remember, it's always change in y over change in x. Increasing by 1. Here I happen to increase by 3. And here I happen to increase by 6. So my change in y over my change in x is equal to, well, that pair is 1 over 1. Change in y is 3 over 3. Change in y, 6. Change in x, 6. So that no matter what, my change in y over change in x does in fact happen to be 1. So what we can do in terms of writing our equation is we know it's always going to start the output, that's y, is equal to something times x, that change in y over change in x, well, in this case that's a 1, plus some number. Well, in order to have that happen, 0 times 1 is 0. Well, I'd have to add 2 to get to 2. So my guess is that this is not really a guess. I think it's 2. Let's check it out. If this is my x value, 1 times 1 is 1. I would need to add 2 to get to the y value. So that 1 times the x value plus 2. Or if we're going to clean it up and write it in proper algebra, we would just simply write y equals x plus 2. So this is me and my algebra brain. This is how I have to work through it, even for the easiest of easy problems. Others of you are not quite so basic. And you see this verbal rule right away. You said, oh, well, that's just x plus 2 right from the beginning. The y values, the output, is just x plus 2. The output is 2 more than the input, is our verbal rule. So we have our verbal rule, our equation, and our table, all meaning the same thing. And that is the end of section 6.